Okay, Calc, here we are doing the 2014 free response questions. So again, you can read through them, try them yourself, and then look at the video if you get stuck or to check your work. So let's look at number 1. Grass clippings are placed in a bin where they decompose. So look, it's a lot like one of the problem we had yesterday, where the gravel was coming in and the gravel was going out. Grass clippings are pushed in and then they just decompose, so they go away. Okay, for t between 0 and 30. The amount of grass clippings remaining in the bin is modeled by this. So this is different than yesterday. Yesterday they gave us an equation that was the rate that the gravel was coming in. This is the equation that tells us how much is there. So yesterday we had to take the integral of that to find the amount. Here we have the amount, so if we wanted the rate, we would have to take the derivative. All right, so let's look at part A. What are they looking for? Find the average rate of change of A of t over the interval 0 to 30. Okay, this is something you need to know. Average rate of change is a slope. An average rate of change is a slope. So all it's asking us to do is use the slope formula. A of 30 minus A of 0 over 30 minus 0. Right? That's all you have to write down, and then you can do the rest in your calculator, and you're going to get negative 0.197. And it says indicate units of measure. What are the units of measure of A? It says pounds. And what are the units of measure of T? Days. Okay, so that is the answer. Negative 0.197 or 196 pounds per day. You get 1 point for part A. Let's look at part B. Find the value of A prime of 15. Okay, that's easy enough. All you're doing is putting that in your calculator. So you can say A prime of 15 equals negative 0.164 or 163. You get 1 point just for that, just for putting that in your calculator and doing it. All right, using correct units, interpret the meaning of the value in the context of the problem. So what I said at the beginning, since A is an amount, A prime is a rate. So A prime of 15 is, you could say, the amount of grass clippings is decreasing at a rate of 0.164 pounds per day at t equals 15 days. That's the kind of thing you need to write. You need to include decreasing or increasing, or you need to put the negative on there. You need to put the rate. You need to say it's a rate. You need to put the value with the units, and you must put the time, because that is only at time t equals 15 days. At time t equals 10 days, you're going to have a different rate. So you get 1 point for that. Let's look at C. All right, find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin. All right, look how it is different from part A. In part A, you needed to find the average rate of change. Now you need the average amount of grass. The average amount is that formula, remember this? 1 over b minus a, the integral from b to a of f of x dx. That's the average amount. Average rate of change is a slope. So this is what we're going to use for this one. So we're going to say 1 over, let's see, it's from 0 to 30. So this times the integral from 0 to 30 of a of t dt. So you're going to go ahead and just do that in your calculator. You don't even have to write out a of t. You can just write exactly what I have here. You could even just write 1 over 30 and then the answer. This is just actually, I don't even have the answer written down. They're asking you for the average amount of grass equal when the amount of grass, which is a of t, equals the average. So here's the average. And here's the amount. So they want to know what t makes those the same. So you can just write this down and then you can just do it on your calculator. You don't have to write anything down in between. You get 1 point for knowing this, and then you can go ahead and find that on your calculator and you get t equals 12.415 days, right? It's days, yeah. Okay, part D. For t greater than 30, so now we're going outside of our time. L of t, the linear approximation at t equals 30, is a better model for the amount of grass. So we're not going to use that model, that a of t, anymore. Now we're going to use, if t is greater than 30, we're going to use a linear approximation and call it L of t. And so we're going to find that, use L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. All right, so we've got to find L of t. This is linear, which means it's a line, which means we need a point and we need a slope. So our point is going to be t equals 30, because they told us that the linear approximation at t equals 30. And then you're going to find, you can find what y is. Yeah, you can find what y is by substituting that into your equation. Right now, I'm just going to call it a of 30. Okay, you can actually find that. The slope is going to be a prime of 30. You're going to take the derivative and find it. So our linear approximation is going to be y minus y1 equals slope times x, which is t here, minus t1. So we can rearrange this and show that the linear approximation is this. All right, you don't even have to put numbers in for those. You can just leave it right like this. You can put numbers in if you want. It's entirely up to you. So you get 2 points for an expression for L of t. Then it says, we're going to use this to predict the time. So that tells us we're looking for a t in which there will be 0.5 pounds of grass clippings remaining. So that means we're going to find t that makes L of t equal to 0.5. So we're going to take this, our linear approximation, and we're going to set it equal to 0.5. And then you are going to find what t equals. You're going to have to put your numbers in, and you're going to get t equals 35.054 days. And that is an approximation using a line. So you get 1 point for that. You get 1 point for setting it equal to 0.5. All right, question 2, we are going to skip because it's a volume question, which supposedly is not going to be on this test, so I surely hope it's not. All right, question 3. Let f, the function f is defined on the closed interval, -5 to 4. The graph of f consists of 3 line segments and is shown in the figure. Okay, and then so we have a graph of f. Remember that what we did yesterday, we had a graph of f prime. So you have to see what they're giving you, just like the first 2 questions. Yesterday they gave us a rate, today they gave us an amount. Okay, so here we're given a graph of f, and we're defining g to be the integral from -3 to x of f of t dt. So let's see what happens here. Part A, find g of 3. So all you're going to do is substitute a 3 in for x. Okay, we're just using this equation right here to find g of 3. So we're going to write it like that. And how in the world do we find an integral of f? Well, when we have a graph, you know that the integral of a graph is the areas under the curves. If it's below the x-axis, then it's negative area, well, negative amounts. So this is going to equal, we're going from -3 to 3. So look at -3 to 2 is a triangle that is 1/2. The base is 1, 2, 3, 4, 5, and the height is 1, 2, 3, 4. Okay, that gives us the area from -3 to 2, and then the area from, and where are we going? We're going to 3, and then we need the area from 2 to 3. That's going to be negative. So I'm going to, well, I can write it as plus, and I'm going to say it's negative. That's a little triangle that has a base of 1 and a height of, is it a base of 1 or a height of 2? A height of 2. So if we do this, we get 2 goes into 4 twice. 2 times 5 is 10, minus 1, and we get 9. You get 1 point for that, for finding g of 3. You have to know what they're testing you here is that you know that the integral of a graph is areas, and they're negative areas if they're below the x-axis. Okay, part B, on the open interval, -5 to 4. On what open intervals from -5 to 4 is the graph of g both increasing and concave down? All right, so increasing, why did I write g? Increasing, now we're doing g, we're looking at g, not f, so do that. Increasing when g prime is greater than 0, and concave down when g double prime is less than 0. So let's start with g prime. G prime is the derivative of the integral, which is just that. Remember how derivative and integrals kind of cancel each other out? So we got that. So for g prime greater than 0, it's the same thing as f greater than 0. What intervals are f greater than 0? Well, it looks like -5 to -3, and -3 to 2. Okay, remember we don't put -3 in there because it equals 0 at -3. And then our second derivative of g is just going to be the derivative of x. If the derivative of g is, f is f, then the second derivative is the first derivative of f, and we want to know where that is less than 0. That is less than 0 when the slope is less than 0. So on those intervals, where is the slope less than 0? Looks like -5 to -3. It's less than 0. Then it has a negative slope. Then it turns to a positive slope. Then it's 0. It turns to a negative slope again, all the way to 4. So we got to see where these overlap. We're down here at -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. All right, so it is increasing from -5 to -3, 5, 4, 3. So it's increasing there, and then from -3 to 2. -3, -2, -1, 0, 1, 2. All right, that's where it's increasing. It is concave down from -5 to -3, and 3, 2, 1, this is 0. And from 0 to 4. So where are those overlapped? Well, they're overlapped right here from -5 to -3, and they're overlapped right here from 0 to 2. So that is where both of those things are happening. And it says in the question, it says, give a reason for your answer. You would say something like, this is where it is both increasing and concave down because G prime equals F is positive and decreasing, or something like that. You could say a lot. There's a lot of ways that you could write your reasons, but that's just one way. All right, let's look at part C. The function h, now we got a new function. The function h is g of x over 5x. And we need to find h prime of 3. So in order to find h prime of 3, we have to find h prime of x. This is a quotient of two functions. So use your quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. All right, and we're looking for h prime of 3. So now we can just substitute a 3 in for x's. And we get that. So we have to find g prime of 3 and g of 3. Well, remember that g is defined as the integral from -3 to x of f of t dt. All right, we already found g of 3 in part A. Do you remember that? We found that g of 3 equals 9. So we can substitute a 9 in for there, and then g prime of x just equals f of x. So g prime of 3, which we need right here, equals f of 3, which you're just going to look on your graph and say at 3, f equals -2. I mean, y equals -2. So that equals -2. So here we have 15 times -2 minus 9 times 5 over 225. And that gives us -1/3. And that's your answer. So you get 1 point for actually getting the answer, and you get 2 points for actually using the quotient rule and finding what the derivative of h is. All right, and now we have one last part, part D. Now we have another function, p of x is f of x squared minus x. Find the slope of the tangent line to the graph of P at the point where x equals -1. So we have x equals -1. To find a slope of a tangent line, you take a derivative. So let's take the derivative of P. That's going to be the derivative of x times the derivative of what's inside, which is 2x minus 1. And then we're going to substitute in -1 for x. That's what it's asking us. So we got to find P prime of -1, which is f prime of 1 minus -1 time, because -1 squared is 1. So 1 minus -1 times 2 times -1 minus 1. So this becomes f prime of 2 times -3. So what's f prime? F prime is the slope at 2. So you're going to have to look at your graph and find the slope at x equals 2. Well, at x equals 2, the slope is the slope of the line that goes between 0, 4 and 4, -4. So you can find the slope of that line. And that is -2. So we're going to say -2 times -3 equals 6. And that's the answer to part D. You get 1 point for your answer, and you get 2 points for taking that derivative right there, using the chain rule. All right, question number 4. It's a table question. You can see what you usually have. You have a table question, you have linear approximation, you usually have accumulation, things coming in, things going out. You're only going to have 2 questions, so I have no idea what they're going to do. All right, question 4. Train A runs back and forth on an east-west section of the railroad track. Train A's velocity is given by the differential function v of a of t, where t is measured in minutes, and there we have some in the table. Okay, find the average acceleration of train A over the interval. All right, average rate, that's an average rate. That's a slope. Acceleration is a derivative of a velocity. So we're just going to find the slope for an average. So we're going to say VA of 8 minus VA of 2 over 8 minus 2. And we're going to find those in the table and say -120 minus 100 over 6 equals -110 over 3. And what is it going to be? This is measured in meters per minute, and this is minute. So this is meters per minute squared. Okay, you get 1 point for that. Part B. Do the data in the table support the conclusion that train A's velocity is -100 meters per minute at some time t with t between 5 and 8? Okay, this is just telling you that you have to use the mean value, the intermediate or mean value theorem. It's velocity. Oh yeah, this is not even the mean value theorem. This is just the intermediate value theorem, because it's asking you for the velocity equals -100, not the rate of velocity, which would be acceleration, where you would have to use the mean value theorem like the one we did yesterday. So for B, you really need to say that V of A is differentiable, because they told you that up there in the directions. So V of A is continuous, because you need it to be continuous, differentiable and continuous, in order to use the intermediate value theorem. So since VA of 8, they're looking for between 5 and 8. VA of 8 equals -120, and VA of 5 equals 40. So since that is the case, you would say, since negative 120 is less than negative 100, which is what they're asking you, which is less than 40, then the intermediate value theorem says that there is at least one t between 5 and 8 such that VA of t equals negative 100. Remember what the intermediate value theorem says? Look at, well, let me draw that difference since it's between 5 and 8. Okay, at 8, the value of velocity is down here at negative 120. At 5, the value is up here at 40. So if this is negative 120 and this is 40, negative 100 is somewhere here. Because this function is continuous differentiable, it tells us it's continuous. There's no way that I can make a continuous function from this 40 to this 120 without it passing through negative 100. No matter what this function does in here, okay, at some point, it's going to cross this line of negative 100. That's what the intermediate value theorem says. All right, let's look at C. I think I need a new page for that. At time t equals 2, train A's position is 300 meters east of the origin station, and the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from the origin station at time t equals 12. Then use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position of the train at t equals 12. All right, now listen. They're giving you 2 times, t equals 2, t equals 12. To look at position, and position is the integral of velocity. So that gives you a clue that you should look at this. Okay, between 2 and 12, the integral of velocity equals position of 12 minus position of 2. You're trying to find this. This is what it wants you to do. It wants you to write an expression that involves the position of the train. So rearranging this formula right here, the position at time t equals 12 equals the position at time t equals 2 plus the integral from 2 to 12 of v of a of t dt. All right, the position at time t equals 2 is 300. They gave you that. Do you agree? And this right here is what they want you to use a trapezoidal 3 subintervals to find the trapezoidal approximation. So if this were me, I would write a little graph because it's just easier for me. If you don't have to write a graph, you don't have to. We're going at 2 and at 5 and at 8 and at 12. Okay? And at 2, it is 100. At 5, it's 40. At 8, it's negative 120. And at 12, it's negative 150. So it doesn't have to be anywhere to scale. So we're going to find this trapezoid. And, oh, this one's hard. We're going to find that trapezoid, I guess, and we're going to find this trapezoid. So what that's going to be, the integral from 2 to 12 of this. Usually we haven't used negative ones, but the distance between 2 and 5 is 3. And so it's going to be 1/2 times the height times the two the two bases. So the bases are 140. Okay, that's the area of the first trapezoid. Then the next one is going to be 1/2. 8 minus 5 is 3. I surely didn't make that to scale, did I? And the two bases are 40 and negative 120. And then the last one is 1/2. The distance between there is 4. And the two bases are negative 120 and negative 150. So you're going to do all of this calculation and you will get, this was supposed to be a non-calculator problem. You're going to be able to use your calculator for every one. So I don't know if they'll give you computations like this or not. So you get negative 450, which is this. So our SA of 12 equals 300 minus 450, which is negative 100, whoa, 150, not 20, negative 150. And you would say, because it's negative, that means it's to the west of the origin. So you could say the position of train A at time t equals 12 minutes is approximately 150 meters west of origin station. All right, that was kind of a complicated one. D, a second train, train B, travels north from the origin station. At time t, the velocity of train B is given by, now we have a new velocity equation. And at time t equals 2, the train is 400 meters north of the station. Find the rate in meters per minute at which the distance between train A and train B is changing at time t equals b. All right, whew, this is a hard one. All right, so what we have here is we have an origin, and train A is going back and forth this way, okay, east and west. And train B is going this way, north and south. So at t equals 2, the train B is 400 meters north of the station. So it's up here. And at time t equals 2, the train A is 100. Is you see how it's positive 100? So that means it's over here. So here's train A. We want to find when is the rate in which, or the distance between them is changing at time t equals 2. So we're gonna, this is a related rate problem. We actually have to make a, I'm gonna call this X and this Y. We're actually gonna have to use the Pythagorean theorem, and we're gonna say X squared plus Y squared equals, what do we wanna call this? D, the distance between them, D squared. I don't care what you call it. Just put something in your somewhere you should probably define that. Okay, so we want to know when, what is, we're looking for, what is D, actually I'm not going to call it D because then that would be DD. That's not good. I'll just call it Z. What is dz over dt when t equals 2? That's what we're looking for, the rate that the distance is changing. So we're going to take the derivative of all of these things. We're going to say 2x times dx over dt plus 2y times dy over dt equals 2z times dz over dt. So all these 2's can just go away. We can just divide by 2. So we get x times dx over dt plus y times dy over dt equals z times dz over dt. This is what we're looking for. So we have to fill in things for everything else. X is 100, correct? And oh, no. X is not 100. The velocity is 100. I'm sorry, I did that wrong. At time t equals 2, the position is 300. So this, and they told us that in part C. Do you see that? At time t equals 2, train A's position is 300. And then in part D, it's told us at time t equals 2, train B is 400. So this is 400, that is 300. So X is 300, and its velocity at time t equals 2 is 100. That's from the table. Y is 400, and its velocity is VB of 2. You're going to have to put a 2 in there into that equation and see what it is. And I think if you do that, you should get 125. And dz over dt is what we're looking for. What does z equal? We're going to have to say 400 plus 300 squared equals z squared. And you're going to find that, and you're going to get z equals 500. And then you're going to solve this, and you're going to get dz over dt equals 160 meters per minute. That's the rate at which the distance between them is changing. All right, let's do question 5. That was an involved question. Question 5, we got twice differentiable functions, f and g, and we got things about them in this table. We got things of f, f prime, g, g prime in the table. So it says for part A, we want to find each relative min of f on the interval -2 to 3. So how do we find relative mins? Well, relative min occurs, and you should probably write this down somewhere, at when f is prime, that was wrong. When f prime equals 0 and changes sign from negative to positive. So where's f prime equal to 0? If you look up there, f prime equals 0 at x equals -1 and 1. But at -1, it goes from negative to negative, so it's not that one. So only x equals 1 is the only critical point where it changes from negative to positive. So that's the relative min. All right, explain why there must be a value c between -1 and 1 such that f double prime of c equals 0. This is that intermediate value theorem. When they tell you something like that, they're asking for intermediate value theorem or mean value theorem. Okay? So we're going to look at, do we have f double prime of -1? No, we don't have any double primes. We only have prime, so that means we're going to, tells you, since it's asking for a double prime, that's probably going to be mean value theorem. So you should say f prime is differentiable, therefore continuous, because you need that in order for mean value theorem and intermediate value theorem. And you're going to say f prime of 1 minus f prime of negative 1 over 1 minus negative 1 equals, okay, f prime of 1 is 0 minus 0 over 2 equals 0. Therefore, the mean value theorem tells you there is at least one t, or x in this case, one x between -1 and 1 such that f double prime of x equals 0. And that's because this equals 0 right here. All right, number C, part C. Now we have a new equation. The function h is defined as ln of f of x. Find h prime of 3. All right, so you got to take, they're testing your chain rule. H prime of x, the derivative of ln is 1 over f of x here, because that's what's inside, times the derivative of what's inside. So since we're looking for h prime of 3, right? Yep. The 1 over f of 3 times the derivative of 3. So f of 3 is 7, and f prime of 3 is 1/2, so this equals 1/14. That's your answer. And then we got to evaluate this. Ooh, look at this. Doesn't this look fun? Okay, this is part D, the integral from -2 to 3 of f prime of g of x times g prime of x dx. Okay, look at this right here. This is like the chain rule. So if we could just go backwards, this just equals f of g of x between -2 and 3. Okay, because if we took the derivative of this, it would be the derivative of the outside times the derivative of the inside, which is right there. So we're just going backwards. So then we're going to say f of g of 3 minus f of g of -2. What's g of 3? G of 3 is 1, so that's f of 1. What's g of -2? That is -1. F of 1 is 2, and f of -1 is 8. So you get -6. Oh, that was kind of fun. All right, let's look at the last one, question 6. Okay, you got a slope field. We have a differential equation and a slope field. So a portion of the slope field is given below. Sketch the solution curve through the point 0, 1. So you're going to go up here to 0, 1, and you're just going to kind of follow what it looks like. It's going to look something like that. Okay, they're going to be really easy on those as long as you're following along. All right, so part B, write an equation for the line tangent to the solution curve in part A at the point 0, 1. Use the equation to approximate f of 0.2. So you need a point and a slope. We got a point, and we need a slope, which means we're just going to take our derivative formula because that's the slope. And we're going to substitute in 1 for y and 0 for x. Okay, so cosine of 0 is 1. So that our slope equals 2 and our point equals this. So our tangent line is this. Is that. Okay. And we're going to use that. We're going to say this f of 0.2 is approximately equal to this, which is 1.4. Okay, then it says, part C, this is going to be the tricky one. Find y, the particular y equals f of x, the particular solution with the initial condition of f of 0 equals 1. So they want you to actually solve this differential equation, which means you are going to separate the variables. So that means we have to put all the y's on the left side. So I'm going to write it like this. And the x's on the right side. So we got that. And then we are going to take the integral of both sides. All right, the integral of this, remember that the integral of 1 over u du equals ln of u, or ln of the absolute value of u. So do we have, if this was our u, do we have the derivative of that? The derivative of this is -1. So I can just stick a negative out in front, and it would be ln of 3 minus y. You can use u substitution if you want. You're going to get that. Okay? The derivative over here is going to be sine x plus c. Now, at some point, we have to find what c equals. We can find what c equals right now, or we can do a little rearranging. I'm going to rearrange a little bit. I'm going to get rid of this negative, so I'm going to say ln of 3 minus y equals negative sine x plus c. This is a different c now. So maybe I'll put in, trying to decide when I want to do it. Let's not do it yet and see what happens. Okay, when I put e to those in there, the e and the ln cancel, and I get 3 minus y equals e to this. And remember, we can write that as e to negative sine x times e to the c. Remember how we can do that? And this is just a new constant, so I'm going to write it like this. And then I'm going to say negative y equals this. Oops, that should be a -3, and y equals 3 plus c e to the negative sine x. So we got to find our y sometime. So let's put it in now and see if it would have been easier to put it in earlier. I'm going to put a 1 in for y and a 0 in for x. All right, what's sine of 0? 0, so e to the 0 is 1, so that just goes away. And I get c equals -2. And so my equation will be y equals 3 minus 2 e to the negative sine x. And that is your answer. So that wasn't too bad to wait there to put it in. You can put it in a lot of different places. All right, so that's the end for this one. Keep working on these or finding some online to work on.